Imagine you're ordering a high-end customized meal at a famous restaurant in Mumbai overlooking Marine Drive. You are paying a premium because you trust the chef to select ingredients that are fresh, safe, ethically sourced, and handled with the highest standards of culinary care. If you discover mid meal that the kitchen secretly switched to unverified mystery ingredients without telling anyone, that trust vanishes instantly, no matter how good the presentation looks. This is the exact trust gap that modern businesses face when they rush to deploy artificial intelligence systems without an established framework of control. In the professional space, we look to ISO/IEC 42001 to bridge this precise gap. Formally, this standard is an international framework that specifies the baseline requirements for establishing, implementing, maintaining, and continually improving an artificial intelligence management system within an organization. To look at it in a more practical way, it acts as a global seal of verification, proving that a company is not simply guessing or playing with sophisticated technology, but is instead systematically checking its data, models, and processes for safety, accuracy, and logic. When organizations skip this critical structure, they are essentially serving automated decisions to their clients while wearing a blindfold. They risk operational failure, legal liability, and catastrophic brand damage because they cannot explain how their technology reaches its conclusions. As auditors, our task is to peer behind the curtain and ensure that the systems generating these outcomes are thoroughly managed, documented, and secure. So, now that we've mastered the core reason for building trust, you might be wondering how that actually translates into a concrete plan within a company. Well, that brings us right into our next step, which is the architecture of AI control. A massive construction project in Delhi requires detailed architectural blueprints, structural engineering inspections, and a highly defined chain of command before a single brick is ever laid. If the project manager simply walks onto the site and tells the construction crew to build something tall and modern, the resulting structure will inevitably crack, lean, or collapse under the slightest environmental pressure. AI governance operates exactly like that foundational set of blueprints. The standard firmly requires an organization's leadership to define the precise scope of its management system, establishing exactly what the AI is authorized to do, where its operational boundary begins, and where its authority ends. Let's ground this with an example you have probably seen at the office. Consider an enterprise that installs an advanced AI system to monitor employee productivity and performance metrics. Without a strictly defined and audited scope, that system can easily experience mission creep, quietly expanding its reach until it begins tracking private employee communications, personal off-duty habits, or sensitive medical leave data it has absolutely no business touching. By drawing a clear, legally binding boundary around the technology, we build a metaphorical fence that protects both the organization and its stakeholders. It is about knowing precisely which components of the machine require constant human oversight and ensuring that the automated loops are operating strictly within predetermined safe zones. So, now that we've mastered the importance of defining boundaries for our AI systems, you might be wondering how we ensure those systems don't become biased over time. Well, that brings us right into our next step, which is the ethics of AI fairness. A hiring manager at a fast-growing technology enterprise in Bangalore uses an automated screening tool to shortlist job applicants from thousands of incoming resumes. But over time, the system ends up systematically rejecting every single candidate who did not attend a specific shortlist of 5 elite universities. Because the underlying machine learning model was trained on historical data that favored those specific institutions, it learned to mirror the legacy biases of the past, completely ignoring brilliant, highly qualified talent from every other corner of the country. This is algorithmic bias in its purest, most destructive form. The ISO 42001 standard does not just ask organizations to be ethical in a vague, superficial way. It mandates that they implement documented, evidence-based processes to actively identify, assess, and neutralize these unfair automated patterns. Stay with me here because this is where the real work happens. As lead auditors, we do not simply accept a company's policy statement claiming they value diversity. Instead, We look for tangible proof that their engineering and compliance teams are actively stress testing their models against diverse real-world datasets, verifying that the algorithms are not defaulting to discriminatory logic. It is our job to confirm that there is a human checking the machine's homework, ensuring that the technology is serving the business equitably rather than perpetuating historical flaws. So, now that we've mastered the art of spotting and fixing bias, you might be wondering how we manage the actual data that feeds these powerful machines. Well, that brings us right into our next step, which is the data quality and lifecycle. A logistics and supply chain firm in Chennai relies entirely on an AI system to map out the most efficient, cost-effective delivery routes across a rapidly expanding urban landscape. If the operations team feeds that predictive system a dataset that includes roads that have been permanently closed for metro construction or bridges that are structurally compromised during the monsoon season, the AI will continually direct drivers into gridlock and dead ends. This brings us directly to the foundational reality of tech development, which is that bad data always yields bad results. The standard places immense weight on data quality, data provenance, and full lifecycle management because even the most revolutionary AI model is fundamentally limited by the information it consumes. Organizations must establish strict checkpoints to verify the origin, accuracy, completeness, and relevance of every piece of data utilized during both the training phase and active production. Think of it like a professional athlete's dietary regimen. If you fuel a high-performance machine with low-quality toxic inputs, its real-world performance will inevitably crash when the pressure is on. As auditors, we must trace the lineage of the data from the moment it is collected through its processing stages and all the way to its eventual retirement, ensuring that the organization's data stream is clean, authorized, and perfectly aligned with reality. So, now that we've mastered the importance of feeding our AI the right information, you might be wondering how we handle the unexpected failures that can still happen. Well, that brings us right into our next step, which is incident response and resilience. An AI-powered customer service chatbot managed by an e-commerce platform in Pune experiences a massive system glitch during a high-traffic holiday sale, suddenly altering its logic and offering a 90% discount code to every single customer who types a specific, completely common phrase. In the corporate landscape, an organization is rarely ruined by the mere occurrence of a technical glitch. Rather, it is judged entirely by how fast its teams activate a kill switch, contain the operational damage, and fix the underlying issue. This is the core focus of incident management and operational resilience within the standard. True resilience means accepting the reality that no system is completely infallible and instead designing a management framework that knows exactly how to fail safely and recover immediately without throwing the business into absolute chaos. I remember observing a tech firm that managed a comparable automated pricing error seamlessly because they had built a pre-approved, highly audited incident response plan. Their automated monitors flagged the anomaly, notified the engineering team, triggered a safe fallback mode, and allowed them to communicate transparently with affected users in under an hour. That level of structural preparedness is the exact line separating a minor, well-managed technical hurdle from a catastrophic public relations and financial disaster. So, now that we have mastered how to recover gracefully when things go sideways, you might be wondering how to make this entire process stick as a long-term business habit. Well, that brings us right into our next step, which is the culture of continuous improvement. A top-tier cricket team preparing for a major tournament at Eden Gardens in Kolkata does not simply play a match, walk off the field, and assume their training is complete for the year. After every single game, the coaching staff and players sit down together to review the video footage, meticulously analyze their fielding errors, identify physical gaps in their performance, and completely restructure their practice drills before the next sunrise. ISO 42001 mirrors this exact operational philosophy by utilizing the classic plan, do, check, act cycle as its operational engine. It demands that an organization never treats AI governance as a static milestone or a one-time compliance chore that can be filed away in a cabinet once a certificate is issued. Because technology, security threats, and global regulations are shifting at an unprecedented pace, our management systems must evolve just as rapidly. As a lead auditor, you are evaluating whether an enterprise has established a living, breathing rhythm of internal audits, management reviews, and swift corrective actions. When a company truly embraces this continuous loop, compliance transforms from an administrative burden into a powerful competitive advantage that builds ironclad marketplace trust. You are now equipped with the complete strategic perspective of why AI governance matters, how it protects human values, and how you will evaluate these frameworks as an expert auditor.